Okay, so let's look at the last question on paper 2, which is question 9, 2020 Higher Level Leaving Cert Maths paper 2. We have two ships, they set sail at the same time, ship A from port A and ship B from port B. Port A is 90 kilometers due west of port B, as shown below. Ship A is traveling due east, so ship A is traveling this direction, at a speed of 15 kilometers per hour. Ship B is traveling due south at a speed of 30 kilometers per hour. Find the distance between the two ships 30 minutes after they set sail. Give your answer in kilometers, correct the 2 decimal places. Because ship A is traveling due east and ship B is traveling due south, we have effectively here a right angled triangle when we're looking at the distance between the two ships after any particular time. So we should really be looking here, when we see right angled triangles, we should be thinking really about sine, cos, tan, or Pythagoras' theorem. In this particular case, we're going to be looking at Pythagoras' theorem, because we'll have two distances, here, and we've got to find the third distance along here somewhere. So let's work out their final distances after 30 minutes from this point here. So let's do A first. So we're going to look at ship A, and it's traveling at 15 kilometers per hour, and the time is going to be 0.5 hours, half an hour, 30 minutes. We've got to find the distance. So distance is speed times time. So that's going to be 15 times 0.5, which is 7.5 kilometers. So that means the distance between A after half an hour and where B started is going to be 90 minus 7.5, in other words 82.5 kilometers. Let's call this point here P, where B starts from. So in other words then the distance then from A to P is going to be 90 minus 7.5, which is 82.5 kilometers. Okay, now let's look at B. So B is just starting at P here, if you like, and traveling south. So B then is traveling at a speed of 30 kilometers per hour. And again, here it's going to be 0.5 hours. So that means the distance that B has traveled, again, is speed times time. So the speed is 30, time is 0.5. So we have a distance then of 15 kilometers. So our final distance diagram will look like this. So we'll have our original point P here. A will be here and B will be down here. This will be a right angle triangle. We know that the distance from A to P will be 82.5 kilometers. And we've seen here that B has traveled 15 kilometers. So we've got to work out the distance between A and B. So it's just simply Pythagoras' theorem. So we can see that the distance from A to B then squared is going to be equal to 82.5 squared plus 15 squared. So that's going to give us 6806.25 plus 225. When we add those two together, then we get 7031.25, and remember that's AB squared. So the distance from A to B then after half an hour is just the square root of 7031.25, and that gives us 83.85. Now we were asked to give your answer in kilometers, correct 2 decimal places. So that's it really. So let's have a look at part B. So T is the time in hours after the ship set sail. Show that the distance between the ships at time T can be given by this function here, where T is between 0 and 6. Okay, so again, let's look at A and B separately. Remember that A is traveling at 15 kilometers per hour over time t. So to find the distance again, if we look at our right angle triangle, this was point P, this is point A, this is where B is now. It's a right angle triangle. To find this distance here, we take the original distance, which was 90, and we subtract the distance that it's traveled. The distance that it's traveled is speed times time, so that's 15 times t. So that's the distance that A will be from P at any particular time t. Let's look at B then. B is just simply traveling at 30 kilometers per hour, so its distance will be 30t. So to find this distance here, the distance between A and B at any particular time, we just apply Pythagoras' theorem. So we have over here 90 minus 15t, and here we have 30t. So we've got to find this distance here then, algebraically if you like. So let's do that. So we have the distance between A and B squared is going to be equal to 90 minus 15t squared plus 30t all squared. Okay, so we just need to multiply all this out, and presumably we'll end up with this function up here. So let's work through this. Well, 90 squared is 8100, and then we'll have minus 2700t in the middle, and then we'll have plus 15t squared is going to be 225t squared. Over here then we've got 30t squared, so that's going to give us 900t squared. When we put all of this together then we do end up with 1125t squared minus 2700t plus 8100. Now that's the distance AB squared, so we just need the distance AB. So we've got to square root all of this, so that's 1125t squared minus 2700t plus 8100. It's the square root of all of that, which is just all of that, if you like, to the power of a half. So that's it. We've shown that the distance between the two ships at any time t can be given by this function up here. Okay, so that's part B. Let's have a look at part C. So part C here is where we have to use calculus to find the value of t when the ships are closest to each other and find that distance between the ships at your value of t. Give the distance in kilometers, correct to one decimal place. So we've got to take our function, our distance function, which is s of t, which is equal to 1125t squared minus 2700t plus 8100 all to the power of a half. What we have to do is find when this distance is at its minimum, at its shortest, when A and B will be closest together. So we've got to differentiate this, let it equal to 0 to find the minimum, and we should be able to work out t from that. So what I'm going to do is work out s prime t, which is going to be a half of all of this, 1125 t squared minus 2700t plus 8100 to the power of, we've got to subtract 1 from a half, so that will give me minus a half. So we've got to differentiate what's inside the bracket as well, so when we do that we get 2250t minus 2700. Okay, so we can just write that as a fraction, so this will end up on top, so we've got 2250t minus 2700. On the bottom then we'll end up with this 2 anyway, and then we've got all of this as well, because this is to the power of minus a half, so that's going to be 1 over all of this here to the power of plus a half. So to the power of plus a half is just the square root, so it's 1125 t squared minus 2700t plus 8100. Okay, so remember this is s prime t, s dash t here. So in order to minimize this, we've got to let this equal to 0. So in other words, 2250t minus 2700 all over twice the square root of 1125t squared minus 2700t plus 8100. We've got to let that equal to 0. Now the only way that this fraction here can be equal to 0 is if the top part is equal to 0. We can't have the bottom of a fraction equal to 0, so the numerator here will be equal to 0. So in other words, that means then that 2250t minus 2700 must be equal to 0. That will give us 2250t is equal to 2700. So that finally gives us, divide across by 2250, that'll give you 1.2 hours. Okay, so what have we found? We have found the value of t when the ships are closest to each other. So the time at which both ships will be closest to each other. And now we've got to find that distance between the two ships at this particular value of t. So what we've got to do now is put this 1.2 into our original function. So we've got to do s of 1.2. So that's going to be 1125 times 1.2 squared minus 2700 times 1.2 minus 8100. So when you do all of that, it's really just calculator work at this stage. You get 80.5 kilometers, and that's to 1 decimal place. Okay, and that's it for this particular question.